If you ever wanted to create your own Python application inside a Docker container, here's what you need to do. I will show you how to set up Visual Studio Code, which extensions you're going to need, how the debugging works, so that you can easily develop and deploy your own application inside a container. Hey everyone, this is Christian and I create tutorials and content for IT professionals here on this channel. I also do a lot of live streaming where I sometimes do coding, code wars challenges or work on my home lab projects. So if you want to learn programming together with me or you want to learn more about Linux, DevOps processes in general, then don't forget to hit the like button and of course subscribe to the channel. In this tutorial, I will show you how to develop Python applications inside a Docker container with Visual Studio Code. And I'm doing this on my Windows 10 machine. Because we're usually using Linux container images because they are very lightweight and easy to deploy Python applications, and they are very scalable, so they can run on container orchestration tools very well, like Kubernetes, for example, or any cloud service providers, we are going to need the Windows subsystem for Linux to do this. So if you're not running Windows 10 and you're using Macintosh or a Linux distribution, you can still follow this tutorial. You can just skip the part with the Windows subsystem for Linux. And as always, you don't need to remember any commands in this tutorial. Just go to my blog and read the full write-up of this tutorial, and then you can just copy and paste all the commands and the templates. Okay guys, so because we can't run Linux containers natively on Windows 10, we need to go and install the Windows subsystem for Linux first, which is a small virtual machine that runs a full Linux operating system inside Windows 10. So you can just use it to develop, run and test your Docker containers locally, which makes development pretty easy. So just go to the official documentation, the Windows Subsystem for Linux installation guide for Windows 10, and follow all these instructions. It's not very difficult. What you basically just need to do is you need to enable two features in Windows 10. The first one is the Windows Subsystem for Linux. Then you enable the virtual machine platform, click OK and restart your computer. Then you go again to this instruction guide and you go to this step 4, download the Linux kernel update package here, download it, follow the instructions, and then it's also recommended to set WSL2 as your default version, because the version 1 is an emulator and not really a virtual machine, so you will gain a lot of performance improvements using this version 2. And then you just open the Microsoft Store, search for Linux and pick a Linux distribution that you're preferring and just go and install this. You can use Debian, SUSE Linux, whatever you want, but I would recommend you to use Ubuntu 20.0 for LTS because it's a very stable Linux distribution that runs very well on Windows subsystem for Linux. And once you've installed this, I would recommend you to use the Windows Terminal application to just run this WSL machine. So Windows Terminal is a very nice application to run a Linux terminal inside Windows 10. You can also use that to manage other shells and terminals, so it's a very nice application. It has a lot of different features. I've done a separate video on how to set up your Windows subsystem for Linux terminal with ZSH and some themes and templates, just awesome. So I'm linking you this tutorial in the description below. Check it out if you want to set up this with ZSH so it looks so nice like this terminal looks, okay? Good. After you have done this and you have set up your Windows subsystem for Linux environment, you should also install Docker Desktop. So just go to the official guide on docs.docker.com and search for install Docker Desktop on Windows 10. It is not really required to run Linux containers on Windows subsystem for Linux, but it is highly recommended because it manages these Linux containers pretty easily, and you can just go to the Docker Desktop, open this application on Windows 10, and then you can see all the Docker containers that are running. You can automatically open them in Visual Studio Code, start, stop them, delete the images, do some cleanups and whatever. So it's very easy, it's very cool, it's a useful application, so I would definitely use that. And then if you open Visual Studio Code, you also should install the right extensions in Visual Studio Code. So there are really just two ones you're going to need on Windows 10 and one that you're going to need on Macintosh and Linux. And the most important one, that is Docker. So just go to the extensions tab and search for Docker and select the first one here. So the Docker extension makes it easy to create, manage and debug containerized applications that you are developing on your machine. So no matter if you're using this on Windows with Windows Subsystem for Linux, on Macintosh or on Linux, it's working very well. It comes with a lot of great and useful features I'm going to use in this tutorial, so this is really required to follow this. Okay, and then you also, if you're running Windows, you should use the remote WSL extension, which will allow you to open any folder in the Windows subsystem for Linux, and it allows you to remotely connect to your Windows subsystem for Linux and use Visual Studio Code just like you would use it on a Linux operating system. So once you've installed those two extensions in Visual Studio Code, you can now connect to WSL2 in Visual Studio Code. And how to do that, you can either click on this icon here on the bottom left status bar, click on this and it will automatically reopen Visual Studio Code. With one difference, you can see in the status bar it is now connected to WSL Ubuntu 20.04, which is my default Windows subsystem for Linux. But there's also another way to open or do this. And this is also pretty nice. So if you're running Windows Terminal and you want to create a new project folder to develop your application, for example, let's create a new folder that's called VSCode example. You can also open remote Visual Studio Code with a code command and then just select a folder you want to open. So when you hit enter, you can see it will automatically open Visual Studio Code, and you can see it's also automatically connected to your WSL machine remotely, which is pretty nice. And we are now in the current folder, we are connected, we can now start developing our Python application. And because I don't have a really good example, let's create a very simple application that will just add two numbers and print out the result, right? So let's create a new file. I want to create a new Python file, so let's start programming, and I want to quickly save this as app.python. So when you see this prompt here, no Python interpreter is selected, you should also select a Python interpreter. It's not really required for Docker development, but if you have installed Python in different versions on this machine, for example, you should select the Python interpreter that you want to use. So in my case, this here. And if you refresh the folder, you can also see there's a new folder created with a settings.json. And here the setting for the Python interpreter is defined. So you could also change this later if you want to do that. But for now, we start developing our Python application. So let's just define two variables here, and let's add a is equal 5 and b is equal 3 and c is equal a plus b. So we will just add those two numbers and let's just print out this. I want to use this syntax to print out the variables here because I think that's a pretty nice way to do it. I also want to print out another statement, why I will show you later. But for now, let's just test and run this application. So as we would usually just test and run code on your Windows subsystem for Linux. So we can open a new terminal here, and then we can just enter Python 3 app.py and it will automatically run. But you could also use the debugger. So for example, if you add a breakpoint here and you click on run debugging, you can see that it selects you to debug a Python file, and it automatically hits the breakpoint, and then you can inspect the variables here. You can step into, step over, whatever, and use the debugger to write your application. It's a pretty great way to develop complex Python applications using the breakpoint feature, which is really nice. But of course, we want to also develop this in a Docker container. And the Docker extension in Visual Studio Code has a pretty comfortable function to generate all the necessary files automatically for us. But don't worry, I will explain all the things what the extension does to you. And of course, you can also go and create all these files manually and customize it. But to start with a very nice template where you don't need to remember every single file you're going to need, that is very, very nice to do. So when you are using the Docker extension, just press the F1 key, and then you can search for add Docker files to workspace. Now click on this. And now you need to select your application platform. So usually we want to use Python if you want to develop other applications, or you want to use Python Flask for web services or Django or whatever. You can also select this. But in our case, we want to use a Python general template. And now we need to select our app's entry point. So this is the main Python file, our main program that the Docker container should execute once it is started, right? And we of course want to select app.py, which is just the only file that we're going to need here. And we could also optional create Docker Compose files. Please leave me a comment if you're interested in doing this. And yeah, I'm considering doing another tutorial on this as well. But in our case, we just want to select no. And you can see it now creates a bunch of different files here. Let me just close all this stuff here and let's go over this step by step, right? So let's go to the project folder, let's refresh it, and you can see there are now a bunch of different files created here. So first we have created two new files, the launch.json and the task.json. We will come to this later, of course. And then we have the docker ignore file. We have our app.py, we have the Docker file and a requirements.txt. So the Docker file is the main file that contains all the instructions how to generate and build the Docker image. We will go over this in a second. The Docker ignore is containing all file extensions or types or names or regular expressions that we don't need inside our container image. So basically what you define here will be ignored by the Docker build command. And we also have the requirements.txt, which is currently empty, but in case you need any libraries, packages or extensions that you usually are installing with a Python package manager pip, you can specify in this requirements.txt file here and it will automatically install all the necessary libraries and packages that you need for your application. And this is a very, very powerful part of Docker containers, because you can run this on any environment, on any Linux operating system. It doesn't really matter what is installed on the host operating system. The Docker container and the requirements make sure that you always have the necessary libraries that you need for your application in the desired version as your application is expecting it. And this is a very powerful part of Docker. I'm not using it in this tutorial, but if you need any Flask application or you're needing any requests, Python packages to do web requests or whatever, you can put it in here and it will automatically be installed. So now let's go over the Docker file, which is a core file, and let's go over these lines step by step. So the first line will define our base image, because we want to build our application on top of a base Linux distribution image. So in this example, the Python 3.8 Slimbuster is a small and a lightweight Debian image with Python 3.8 installed. So that has everything we're going to need to write basic Python applications. If you're interested in learning more about building Docker images or specific version, whatever, put a comment, because I don't really know what to grade for you guys. So please let me know. The next line is ignoring all these PyC files inside our container. So we don't really need that inside a container. It's just annoying. So we just will prevent Python from generating these. And this is also turns off buffering for easier container logging. So this will just make container logging a bit easier to analyze. And then we are installing all the pip requirements. So this is just what I've said before. It will copy the requirements.txt, and the dot stands for our current working directory. And then it will run the Python command with the pip package manager and install everything that is defined inside our requirements.txt file. Then it will set the working directory to /app and copy all files in the entire project folder inside our /apps directory. So when you later run this container and you connect a shell to this container and do an ls command inside the /app directory, you see that all the entire project folder inside here will be copied to this location. Then we also want to add a new user, disable the password, and give some limited privileges to this user. So this is highly recommended because of security reasons, because usually when you run a container, it will execute everything with root user's privileges, and this can be a security concern if for whatever reason your Python application has some security vulnerabilities and it is abused by any hackers or malware. It could potentially lead to privilege escalation and very bad things that can infect even the host operating system. So it is always required, or it's always recommended, to isolate your application from the host operating system by adding a non-privileged user here. So I'm not seeing this in all Docker templates, and that can be a real problem. So make sure you're always using this. If you want to learn more about it, then just go to the link and read about it. And then our last command will just execute the Python command with our app.py. So this will just run our application, and once our application exits, it will automatically also exit the container. But now we just want to build our container image and run it. And because Visual Studio Code has prepared everything for us, we can now just go and execute the docker build dot to build this image, or simply just click on the Docker file with a right click and say build image. So this will automatically build this image, and once this is done, it usually shouldn't take long because this application is very, very simple, right? We can now exit the terminal, and if we execute a Docker image list, you can see that it just currently built another image that is called VSCode example, just like our project name is without the dash. It's built 7 seconds ago. It has a size 116 megabytes. And now we can just run our container. So let's execute the container with the docker run VSCode example. We can just now use our image that we will locally start. And you can see it just printed out 5 plus 3 is 8, program exited. And if we execute the docker ps, we shouldn't see our container because it is not running anymore. But if we execute the docker ps-all, you can see that this container has just run 12 seconds ago and it is still stored in our system. Okay, so this is pretty nice. This is basically everything you need to do to build your Python application inside your Docker container. It's not really that complicated, to be honest, but I think the most concerning part for me always was, how do I do debugging inside a container? Because the container is an isolated environment. How can I connect the debugger to this? And this is very, very beautiful. The Docker extension makes it pretty easy for us to debug this application inside the container with no effort at all. So in the past, I needed to install and use debugging libraries and extension in Python, but you don't need to do this anymore. The extension is smart enough to rewrite our entry point inside the Docker file here. You can see it in the comment. So you simply just can go to run and start debugging, and then it will automatically debug it. Let's also add some breakpoints, and I can show you how easily this works. So click on start debugging, and it will automatically build our container and connect a debugger to it. And then if we execute it, you can see it immediately hits this breakpoint here. So when we go to the debug section here, you can see that we're currently at this point here. We can also inspect the variables and see that C has a variable of 8. If we continue, you can see it steps to the next breakpoint. You see the output on the terminal here. The variables will change if there is anything to be executed, and if we hit continue again, the program exited and the debugger stops. It works pretty well. And this is very, very cool. It makes it very easy. But how is this possible, right? So you can see the Docker extension has also created 2 new files here, and this is first the launch file and the tasks file. So when we look into these files, you can see that there are some JSON configurations that change, or they hook at specific points of these actions here, what you execute. The start debugging action, for example, is this hook here. And it do a pre-launch task. You can see the Docker run debug. So if we want to know what this task is doing, we need to go into the tasks.json file and see, there is a task that has this label Docker run debug, and it depends on the Docker build task. So first of all, it will execute this Docker build task, which will basically just build the container, set a tag to VSCode example latest. So if you want to customize your image tag, if you want to customize a specific version, whatever you want to do, you can also customize it here. It also has the Docker file in the context, and then it automatically runs this container. You can see it runs this file, and it starts with a debugger. And of course, you can now just go and push this container image to your private registry or to the public Docker Hub registry, where other people can just pull down the image and use your application very, very easy, no matter where they deploy it. If they deploy it in a Kubernetes or container orchestration tool, whatever, doesn't really matter. The Docker image will always run with the defined requirements and libraries you specified inside your Docker files. Okay guys, so I hope this tutorial helped you to deploy your Python application inside a Docker container with Visual Studio Code very easily, and you can now just develop your Python application. You can do some amazing things and deploy it on any container orchestration tool or on any cloud provider with Docker containers very, very easily. By the way, if you're interested in other Python projects or how to push this to a private container registry and how to use CI/CD pipelines and DevOps processes to deploy your applications automatically, then again, don't forget to hit the like button and subscribe, because I'm planning to do more tutorials on this. So please leave me in the comments what you want to see and what your current projects are, what you're working on. And if you're struggling somewhere, then again, just join our Discord community. We have a very friendly and respectful community of many talented IT professionals. I'm very proud of you guys. So check it out. It's always a lot of fun to chat with you guys. Okay, so thanks everybody for watching. Enjoy the rest of your day. Take care of yourself, and I see you soon. Bye bye.